Hey guys, today we're going to be learning distributive property. So the learning target for today is we will be able to apply distributive property with rational coefficients. So let's just talk about normal multiplication and how we could use an area model to represent that. So 5 in parentheses 13, this is the exact same thing as 5 times 13, or 5.13. This is all multiplied. Any number directly next to anything in the parentheses means multiply. So if I have this, that means 6 times 20, or this, that means 5 times 2. So we are going to rewrite 13 so we can split it up between what's in the 10th place and what's in the ones place. So 13 can be written as 10 plus 3. 13 in the 10th place is just 10, and in the ones place it is 3. So now if I wanted to, I could use an area model. You guys learned this in elementary school. This is just kind of a brief reminder. My 5 will go right here because there's nothing in the tens place for 5, so it's just one number. And then I can split this in half and have 10. Whoops, that's not where the 10 will go. 10 right here, and then 3 right here. So 5 times 10 is 50. 5 times 3 is 15. If I were to add those together, I would get 65. That is how we just multiplied 5 times 13. This is similar to when you guys first learned multiplication and we could do 22 times 27. Since both numbers have a number in the 10th place and in the ones place, we will have 4 squares. I can put my 22 on the side, so 20 and then 2, and then the same thing with 20, which you can't even see, and 7. 20 times 20 is 400. 20 times 2 is 40. 20 times 7 is 140. 7 times 2 is 14. And if I added that all together, that would give me 22 times 27. So that part you didn't exactly need to write down. We just wanted to refresh you guys on the area model and how we will use that for distributive property. So what is distributive property? Distributive property says that you will multiply a sum or a difference by a given number. You will multiply each number in the sum or difference by that number that is outside of the parentheses. And we can use distributive property to simplify algebraic expressions. So a sum, remember, that is when something is being added. That is a sum. Difference is when something is being subtracted. Just a reminder. So let's start with 3 times 2x plus 4. Let's zoom in here a little bit. So I am going to make an area model with my 3 and then my 2x plus 4. So 3 is just one number and it is not in the 10th place, so I can just write it out like that. And then I can split my rectangle in half. I'll have 3 right here, then 2x here, and 4 right here that we are adding. So think of it as this 3 wants to multiply to the 2x, and it also wants to multiply to the 4. It is multiplying by both of those, and then they will add together at the end. You'll take the sum of it. So I'm going to start with my 3 times 2x, which will give me 6x. I will multiply the coefficient by the constant, and then I will keep the x the same. The x does not change, so that will become 6x. Then I'll do the same thing for 3 times 4, which will give me 12. Now I could rewrite this as 6x plus 12. And if you remember from Friday, these are not like terms. One is a constant and one is a coefficient. There's a variable next to it, so I would have to leave it like that. So 3 times 2x plus 4 equals 6x plus 12. All right, we're going to do the same thing for the next one. This time we are taking the difference. However, the only difference is instead of adding at the end, we are going to subtract. So I'm going to draw my rectangle again. The number on the outside of the parenthesis I can put on the left, which is 6. And then I can put my 7m on one side and 5 on the other. Now I can draw my arrows again. My 6 is being multiplied to my 7m, and it's also being multiplied to my 5. So 6 times 7m, I'm going to multiply those two numbers like normal and keep the variable. 6 times 7 is 42, and I'm going to add the m, just like normal. And then same thing for my 5. 6 times 5 is 30. And now since we have a subtraction symbol this time, instead of adding them together, I'm going to rewrite it as 42m minus 30. So 6 times 7m minus 5 is the same thing as 42 minus 30. It was just simplified. 42m minus 30, sorry. Oh my goodness, okay. So now we're going to do a few more. I'm going to make my box again for this one. Just a little rectangle. 4 on the outside. And then I can split this in half. N first and then 5 first. So this number goes right here. This variable goes right here. And then this number will go right here. So 4 times m. Think of n as 1n. It's the exact same thing. There's only one n. 4 times 1 is 4, and then we're going to keep the variable the same. So 4 times n is 4n, and then 4 times 5 is 20. Since we are adding, this can be rewritten as 4n plus 20. All right, and then we're going to do the same thing over here. I'm going to draw my rectangle. I'm going to put my number on the outside of the parentheses on the left, -12, and then my 2y will go right here, and my 3 will go right here. -12 times 2y, a negative times a positive is going to be a negative. We know that. So I can put negative. Now, -12 times 2 will be -24. And then I'm just going to keep my y the same. And then -12 times 3 is -36. So this can be rewritten as -24y minus, because we're subtracting, -36. And if you guys remember from our integers unit, I can also rewrite this as -24y plus 36, because when these two are together, they will make a giant plus sign. Subtracting a negative number is the same thing as adding the positive number. All right. Hopefully you have gotten the gist of this. If not, you can continue doing the area model for the rest of these. I am just going to use the arrows for these next two. So I have 9 times 3n plus 1. Now, when I was taught this in school, we were always taught to think of Angry Birds. You guys may not have played that game because that came out like forever ago, but think of it as you're shooting your Angry Bird to hit your first term, and then you also want it to hit your second term. So 9 times 3n is 27n. And I'm adding, so I'm keeping the addition symbol. Then 9 times 1 is 9. So 9 times 3n plus 1 equals 27n plus 9. Now I'm going to do the same thing for the next one. I can rewrite this as 10 minus 7y minus... Sorry, I don't know why I just said that like that. We're going to have to backtrack. Start over. 10 times 7y minus 9. Now I'm going to shoot my Angry Birds again. I want it to hit my first term and my second term. And I know we're subtracting, so I'm going to keep the subtraction symbol. 10 times 7y is 70y. And I'm going to keep my subtraction symbol. And 10 times 9 is 90. Now I can say that 10 times 7y minus 9 is 70y minus 90. All right, so what happens when you have 3 terms that are being multiplied by a number outside of a parenthesis? So I'm going to go ahead and make my rectangle again, my area model, just so we can visually see. My 6 will go on the outside because that has the number on the outside of the parenthesis. And instead of splitting it in half, I'm going to split it into 3 pieces because there's 3 terms. I'm going to write my 2b first, then 8c, then 3. Now I'm going to start with my first arrow. 6 times 2b is 12b. Then my second arrow, 6 times 8c is 48c. And 6 times 3 is 18. Now I can rewrite this as 12b. And there's a plus sign here, so I'm going to keep the plus sign, plus 48c. And since there's a subtraction sign here, I'm going to add a subtraction sign and then my third number. So there's 3 terms in the parentheses, and we end up with 3 terms that have been multiplied by that outside number. So let's do the same thing here. If you can go ahead and just draw your arrows and see that you are multiplying each term by that number, you can just go ahead and do it. If not, I'm going to make an area model here. I'm going to do my rectangle again, just like this. I'm going to split it into 3 because there's 3 terms. My 3 will go on the outside. My 3m will go on the first square, then 5, then 11n. So 3 times 3m is 9m. 3 times 5 is 15. And 3 times 11n is 33n. Now this can be written as 9m plus, we have a plus sign there, 15 minus 33n. So we started with 3 terms inside the parentheses and still ended with 3 terms. Okay, so what happens when you have a complex expression? You are going to do the exact same thing. You are just going to multiply each term inside the parenthesis by the fraction that is outside. So I would have 1/2 times 2 plus 1/2 times 6y. So for this one, I'm going to make an area model. And I'll split it down the middle because there's 2 terms. My 1/2 could go to the side. My 2 will go on top, and my 6y could go to the top. Now at this point, you are free to use your calculator, but I know that multiplying by 1/2 is the same thing as dividing by 2. So 1/2 times 2 will equal 1, and 1/2 times 6y will equal 3y. We're going to multiply like normal, even if it's a fraction, and just keep the variable the same. So then this can be rewritten as 1 plus 3y. So when you are multiplying by a fraction, unless it is an improper fraction, usually, well, all of the time, your terms that you started off with will become smaller afterwards. So now we have 3/4 times negative 12z plus 36. I'm going to make my area model again, just like this, splitting it in half because there's two terms. My 3/4 will go to the side. Then I will have a negative 12z and 36. So I can say that 3/4 times negative 12 will equal negative 9z, because we have a z, so we're going to keep our variable. And then 3/4 times 36 will equal 27. So now this can be rewritten as negative 9z plus, because we're adding, 27. And again, our terms are smaller than they started off with, because if we multiply by a fraction, our numbers will get smaller. Okay, so same thing here. I'm going to make an area model just for those of you that like it. Of course, if you are able to just visually see that each thing or each term is being multiplied by the outside number, then you can just do that as is. So if I wanted to, I could do negative 1/3 times 2 minus negative 1/3 times 3x plus negative 1/3 times 3. But for this one, I'm going to make my area model again. So I'm going to have negative 1/3 on the side. And I'm going to split this into 3 because we have 3 terms. So I'll have 2 at the top, 3x, and 3. Now, since I have a negative number outside of the parenthesis, my signs of my inside terms are going to switch. So I have negative 1/3 times 2. Which will give me negative 2/3. And I'm keeping the negative because a negative times a positive is a negative. Now we're going to do the same thing with 3x. Negative 1/3 times 3x is a negative x, or you can write negative 1x. They're the same thing, and then I'm going to do the same thing again for negative 1/3 times 3, which is just negative 1. So now I'm going to rewrite this as negative 2/3 minus, because we have a subtraction symbol here, negative x plus negative 1. And if I wanted to, I could rewrite this as, I'll rewrite it right here, negative 2/3 plus, because we remember from our integers unit that a negative right next to a subtraction symbol will make a big plus, x. And if I wanted to, adding a negative is the same thing as subtracting, so I could write it as this. These are both the same thing. You can leave it either way. This just helps me simplify it more. Okay, so one more time, I'm going to make my area model. Long rectangle. Number on the outside of the parenthesis will go on the outside of the rectangle. And I'm splitting it into 3 because we have 3 terms. 10 at the top, 15m, and 20n. Now, at this point, I would recommend using your calculator. It will just be faster. So 2/5 times 10 is 4, but since we have a negative being multiplied to a positive, it's going to be a negative 4. So negative 2/5 times 10 is negative 4. Now we're going to do the same thing with 15m. So negative 2/5 times 15 is 6. Sorry, negative 6. And we're going to keep our variable the same, so negative 6m. And then negative 2 over 5 times 20 is -8. And again, we're going to keep our variable. So our term started off being all positive, and since we multiplied by a negative number, we ended up with negative terms. So now I can rewrite this as a -4 plus, so we have a plus sign here, -6m minus, because we have a subtraction symbol, -8n. And if I wanted to rewrite this, I could write it as, I'll do it really small at the top, -4 minus, because a plus symbol next to a negative, adding a negative is the same thing as subtracting it, 6m, and we remember from our integers unit that when a negative and a subtraction symbol are right next to each other, we can add it. So we started with 3 terms, and now we ended with 3 terms. So that is distributive property.